Hey y'all. Today's lesson is about finding slope. Okay, mine's cut off. Finding slope by rise over run notes. Finding slope by rise over run. We've talked about rate of change, about how fast or slow something changes over time, and that is going to relate into slope. So slope, by definition, is how steep a line is on a graph. How steep or how flat a line is. And there are four types of slope. So I'm just going to show you right here. There's a positive slope, there's a negative slope, and then there's a zero slope, and an undefined slope. Not unidentified, undefined. And I'll just explain. The positive slopes are like if you're riding a bike and you're going up a hill. Those would be like positive slopes. And we read from left to right. So when we're talking about slope, we're looking from left to right. A negative slope is going to be going like riding a bike down a hill. And so if you are riding a bike up a hill, you have to put forth a lot more energy. And so I like to think about that as positive because you are exerting a lot more energy, a positive amount of energy. If you get to the top of the hill and now you ride down, you kind of get to coast. Like you don't have to pedal. You're getting to catch your breath and you're relaxing. And actually, if you try to pedal, it's almost like the pedals are going too fast for your legs. So if you're going downhill, you're negative. It's like the negative. Zero slope is just a horizontal straight line across. And that makes me think like if you're riding your bike on a flat surface, once you pedal a little bit, then you can just take your feet off and you don't have to pedal. Or you just put, stationary, and then you pedal a little bit, but it's like zero effort. Like it's just easy, zero. And then an undefined slope is a vertical line, and you cannot ride your bike up a wall. So that's like what I think about. When I was in algebra, my teacher taught me you cannot ride your bike up a vertical wall. So that's undefined. If you ever have a vertical line, that's an undefined slope. So I'm going to teach you how to find slope by using rise over run. Rise, and I put the steps up here. You count your rise. First you're going to go up or down, and then you count your run, and that's left or right. Whoops, I forgot my parentheses. So the first thing you have to do is you have to identify 2 points in the graph. Now, they need to be like integer points. They need to be intersecting at a nice place. And so most of the points on here I found for you. So looking at number 1, we have 2 points. And it doesn't matter which side you start with. I'm just going to start on the left because it's just easier to start on the left. And I need to count my rise and my rise. So I need to go up or down. So to go from this point to this point, I need to go down. 1, 2, 3, 4, 5, 6. So I went down 6. Now because I went down, that's negative. This is a negative slope. If you were riding your bike, you'd be going downhill. But because I counted down, it's negative 6. Then from that point right there, I need to count my run. I need to go right. Let's see, make sure I'm okay. 1, 2, 3, 4. So negative 6 over 4. That's how I start. I found 2 points. I counted my rise and then my run. Now I need to reduce my fractions. No mixed numbers and no decimals. When you're going to do slope, you just want to leave it as a fraction or an improper fraction. So I can divide both by 2, and I get negative 3 over 2. And that's my slope, negative 3 over 2. All right, so let's do number 2 together. Again, you need to find 2 points, which I've already found for you. And now we're going to count our rise. So in this slope, this is positive. So I'm going to start on the left dot, and I'm going to count up. 1, 2, 3, 4, right here. So I went up 4. And now I need to count over. Let me make sure I'm at the right. 1, 2, 3, 4, 5. So again, it's rise over run, 4/5. I can't reduce 4/5. It's positive, so my answer is just 4/5. So that's my slope, 4/5. When we did rate of change, we had units with it, like $4 every 5 something. But when it's just a slope, it's just going to be 4 over 5. All right, number 3. This is a negative slope, so we should have a negative somewhere. I'm going to start on my left, and I'm going to count down. 1, 2, 3, 4. And now I'm going to count over 1, 2, 3. So negative 4/3. I can't really reduce it, so negative 4/3 is my slope. All right, so you try number 4, pause it. You try to find the slope of number 4. You have the 2 points. Remember to count rise over run. Press play when you're ready. So the slope would be 5 over 2, 5 halves. Did you get 5 over 2? It's a positive slope and up 5 over 2. All right, so this is number 5. Okay, so number 5, we're going to count up. So it went up 1 and over 2. So my slope is 1/2. Now, a common mistake is students will go the wrong way. Students will go over first, 2 over 1. But remember, rate of change is the change in y over the change in x. And the slope and the rate of change are like the same thing. It's just the slope is just going to be a number and the rate of change is going to be more with word problems. But these are all linear equations, linear relationships. And so the slope is just counting the change in y over the change in x, or rise over run. Now on number 6, you have your coordinate plane, you have your axes, and here is the line right there. I don't know if you can see it. This is a vertical line. And so we already kind of talked about what the slope is going to be, but let me explain why the slope is undefined. Okay, so the answer is undefined, and let me explain why. You need to count the vertical change. So we need to pick 2 points. We're just going to pick that point and that point because they're all on the grid. So I picked 2 points. You pick those 2 points. Now, how much did it change vertically? 1, 2, 3. Well, it went up 3. Or 1, 2, 3 went down 3. Either way, up 3 or down 3. How much did it change left or right? What would our run be? We rose 3, but did we go left or right? And the answer is no. You cannot divide by 0. If we type this in our calculator, it's going to tell us an error because you can't divide by 0. So that's why it's undefined. It's undefined because it has no lateral change. It has no x value that changed. So a vertical line is undefined. Number 7, you try 7, pause it. You try 7 and press play when you're ready. Okay. -5/4. You can't reduce it, so just -5/4. I hope you got that one correct. On number 8, you see the 2 points right here on the graph. Again, this is a horizontal line. And we can find the slope, how the change in y, how much did it rise? Did it go up or down from here to here? Did it go up or down? No. So my vertical change is 0. How much did it change horizontally? So it went over 1. And when you type in 0 divided by 1 in your calculator, you get 0. So this is a 0 slope. Do you see the difference? This one, the vertical line, the 0 is in the denominator. You cannot divide by 0. But if 0 is in your numerator and you divide by 1 or 2 or whatever, then you're still going to come out with 0. This is like riding your bike. You can ride your bike along a flat, straight street. You cannot ride your bike up a wall. So a 0 slope and an undefined slope. Those get confused a lot. All right, on number 9, you don't see the 2 dots on the line. So we need to find 2 dots, and they need to intersect nice and neatly on the grid. So I see 1 right here, and then I see 1 on each side. So I actually see 3. If you have more than 2 points on your line, it's okay. I'm just checking the time. It's okay. I'm going to show you actually they would all reduce. So I'm going to go from the farthest left all the way to the farthest right. So I'm going to count my slope. Again, this is a positive slope. So my rise, 1, 2, 3, 4. Over run, 1, 2, 3, 4, 5, 6, 7, 8. And I can reduce 4/8 to 1/2. So that's like, I'm just going to kind of draw a triangle for you. Do you see the triangle I made? But now I'm going to just go from the left to the middle. Instead of going all the way across, I'm just going to go from the left to the middle, and I'm just going to make a little smaller triangle. So if I counted my rise, it would be up 2, and my run, 1, 2, 3, 4, which also reduces to 1/2. And then I didn't even see it, but there's also another point at which it crosses very evenly. So again, if you picked farther points, you just have to reduce. If you pick closer points, then it would have been up 1 over 2. So this slope is a positive 1/2, a positive 1/2. And just comparing these two slopes for a minute. We have 5/2 and we have 1/2. So this number is bigger. We should see that 5/2 is bigger than 1/2. And look at the line. This line is a lot more steep than this line. This line's a little flatter and this one's real steep. And so slope, the value of your slope is directly related to how steep your line is going to be. The bigger the slope, the more steep it's going to be. All right, so number 10. A hiking trail rises 6 feet for every horizontal change of 100 feet. What is the slope? So again, the slope is the change in y over the change in x, just like rate of change. So it rises 6 feet. That is your change in y. That's your rise. And it's rises, so that means it's positive. For every horizontal change of 100 feet. So horizontal. So 6/10, which you can reduce to 350. So the slope would be 3/50. I just divided by 2. Okay, so last one, we have a picture of a slide, and this slide is 18 feet and 40 feet. So I'm thinking it wants us to find the slope. So it's the change in y over the change in x. So it is going, now if you're looking at this slope, do you see? The slide, okay, I'm just going to double check and make sure. So this slide has, from left to right, it has a positive slope. I know that you go down a slide, but the angle or the direction, I guess, of the slide is a positive. So the horizontal change would be 18, and the, whoops, did I say horizontal? The vertical change is 18 because you would go up 18 feet, and then the horizontal change is 40, and you can reduce and you get 9/20. So the slope of that slide is 9/20. So again, we will practice more with slope in class. Whoops, I pressed the wrong